All right, good afternoon, everyone. Thank you for joining us today. So today I'm going over our Wi-Fi 7 access points. The last time I did this webinar, we had two Wi-Fi 7 access points, and we now have three. We're going to start off by talking a little bit about the technology that's part of Wi-Fi 7, and then we'll break down the three different models, talk about the applications for Wi-Fi 7, and give you some ideas what the differences are between the different models. If you have questions as we go through today, use the Q&A part of the Zoom interface to send in those questions. And I should be able to then see those as I'm presenting, and depending on what the question is, I will answer it. So we've already got a question. Let's start with the first one. Will Zyxel be offering an outdoor Wi-Fi 7 access point? And the answer to that is yes, we will. Nothing has been announced yet. It will be probably sometime next year. The challenge with Wi-Fi 7, or specifically with deploying Wi-Fi 6, is there are very different rules put in place by the FCC when using 6 gigahertz outdoors versus using it indoors. So for indoors, it's just standard unlicensed use, which means that you treat it just like any other access point. For deploying Wi-Fi 6, or excuse me, 6 gigahertz Wi-Fi outdoors, you're having to share the spectrum with existing licensed 6 gigahertz users. So because of that, there is a third-party system you have to integrate into your access points, including geolocation of the access points themselves, that basically every 24 hours has to check which other licensed users may be in the area, which channels they're using, and then in turn the access point has to blacklist those channels, and in some cases reduce the power output on the channels they can use so as not to cause interference with the existing licensed users. So those systems were just finally given FCC approval. I want to say it was May of this year. So we are looking at getting into that space, and it will be sometime next year. It's going to take some time here for us to make the new hardware, to find out which of those third parties we're going to be able to integrate with, set up the business relationships with them, etc. So they are coming, but probably next year. And that's why it's taking a while to get Wi-Fi 7 outdoor access points. So we'll go ahead and start with the presentation. Maybe. There we go. So we'll start by talking a little bit about the technology. So Wi-Fi 7 is also known as 802.11be or just 11be. So 802.11be is the IEEE standard that Wi-Fi 7 is based off of. Wi-Fi 7 is a marketing term that was put into place by the Wi-Fi Alliance, which is a group of primarily manufacturers of Wi-Fi equipment designed to help promote Wi-Fi technologies, as well as solve some of some interoperability issues between different vendors. So this is just showing here sort of the timeline of Wi-Fi 6 to Wi-Fi 6E, and now Wi-Fi 7. So one of the things you may notice here is it's been a very compressed timeline between when Wi-Fi 6 hit the market and when Wi-Fi 7 did, compared to older technologies such as 11AC, which was released a long, long time ago. So that is something that has happened here. And part of that, with the differences why we have this intermediate step between 6 and 7 called 6E, just has to do with the timing of when the FCC opened up 6 gigahertz for unlicensed use. So Wi-Fi 7 is the latest technology. And one of the challenges we have with Wi-Fi 7 at this point is just that there aren't a lot of clients out there that support Wi-Fi 7, and those that do may not support all of the features. And this is something we've seen in the past. Client technology takes more time to launch versus the access point technology. So a lot of the Wi-Fi 7 deployments today aren't going to see a lot of Wi-Fi 7 users. It's a matter of future-proofing your network and getting it ready for those users once Wi-Fi 7 becomes more widespread in client devices. And that just has to do with the fact as we go up to each new Wi-Fi standard, they add in new technology, they add in faster speeds, which are more energy demanding. So obviously, one of the challenges with wireless is most of your wireless clients are portable devices that operate off batteries. So it takes time for the chipset technologies to become efficient enough that makes sense to be able to fit that technology into a battery operated device. Um, so just going on here, probably the biggest change from the old Wi-Fi to Wi-Fi 7 and also technically Wi-Fi 6E was the opening up of the 6 gigahertz spectrum. So you can see here visual representation of the size of 2.45 gigahertz and 6. So you see here 6 is actually larger than 2.4 and 5 gigahertz combined. So this opens up a huge chunk of spectrum for us that helps solve some of those lack of bandwidth issues we've had in the past. In the US here, 2.4 was limited to around 60 megahertz of available bandwidth. The smallest Wi-Fi channels are 20 megahertz. So that meant that as soon as you got to more than 3 access points, you were overlapping channels and causing interference. If you jumped up to 40 megahertz channels, you were stuck with just one channel that could be used. So as soon as you added a second device, you run into interference issues. 5 gigahertz helped open up for us. I want to say it was 26 channels of 20 megahertz. But people took advantage of this extra spectrum to widen the channels out here. So you saw a lot of products using 80 megahertz and with 11AC wave 260 megahertz. So once you jump up to these bigger channels, which give you faster speeds, now you're down just to 2 channels that are available at 160 megahertz versus 6 gigahertz, where you've got 7 channels operating at 160 megahertz with no overlap. So that means you can have a lot more users, a lot more access points in the same space without worrying about signal overlap. Now, there is a trade-off with 6 gigahertz, and that is that the range is less. So with RF technologies, as frequency goes up, range goes down. Basically, the signals lose power quicker as the frequency goes up. So because of that, if you're upgrading an existing 5 gigahertz network to 6 gigahertz, you may find yourself in a situation where you need to add some additional access points or rearrange the access points you already have to take into account the fact that the 6 gigahertz isn't going to cover and propagate the same way that 5 gigahertz did. So some of the other technologies here that are part of Wi-Fi 7. So one of the biggest claims here is going to be speeds of up to 46 gigabits per second. Obviously, that's going to depend on the hardware, both of the client and the access point. And currently, we do not make anything that goes up to 46 gigabits per second. Our fastest Wi-Fi 7 access point can support speeds of over 20 gigabits per second. Some of the ways we did that here was by doubling the bandwidth. So now, since we've got all this 6 gigahertz spectrum to play with, so Wi-Fi 7 gives us the ability to use 320 megahertz channels in the 6 gigahertz space. So you double the bandwidth that your channel is using, you double the throughput that's capable there. They've changed the encoding on strong signals from 1024-bit QAM to 4096-bit QAM, which gives you about a 20% data speed increase. And then the other big technology here, one of the biggest ones, is called MLO, multi-link operation. So in all these years since the late 90s when Wi-Fi first came out until Wi-Fi 7, your client device and your access point would always communicate on a single radio. So while your access point may have 2 or 3 radios built into it, a 2.4 and 1 or 2 5 gigahertz radios, your client devices would only ever connect to one of those. So MLO now opens it up and allows you to connect to multiple radios between the client device and the access point. So what this does is it gives us 2 different options depending on how we want to take advantage of that. It can give us lower latency. So to get lower latency, so one of the challenges we have with RF technology, right, is it's radio waves, it's unlicensed spectrum, there are going to be interference, there are going to be packets dropped. So that means when we're dealing with Wi-Fi, you see a lot of retransmission of packets and the need to send them multiple times. And that's part of the reason why, the advertised speed or data rate that you see on a data sheet is usually about half of what you see with a speed test, is because you're having to resend a lot of that data to actually get it through. So with MLO, you can send the same data across two different radios, say your 5 gigahertz radio and your 6 gigahertz radio, and you aren't going to see the same interference and the same drop packets across both radios. So it reduces the number of retransmits you have to send. So basically, you're sending the same data over two streams, and then you combine them back together for one, reducing how much needs to be retransmitted, thereby lowering overall latency and jitter. Or if you don't care about latency, you can split your data stream across both of those radios. So different data is going over each and then combining them together for a faster single stream of data, essentially. Now, as things stand right now with MLO, I am unaware of any client devices out there that support more than two radios. So that's what you're looking at. I'm not aware of anything even on the roadmap that's going to do more than that. So generally, it will be two of the three possible radios that MLO will support. And again, obviously, if you're operating two radios, two amplifiers, two sets of antennas, it requires a lot more power to do that. So again, it's one of those things where a lot of client devices aren't going to support MLO simply because of the hit it's going to put on the battery and runtime on that battery. Now, obviously, over time, as things get more efficient, hopefully that'll change. But that is to be aware, there are very few clients out there that support MLO currently. Another technology we have here is called multi-RU puncturing. And basically, this is when you're using those larger channels. It allows you basically the access point to be able to detect interference or overlap with another neighboring device that's using an overlapping chunk of that large channel and basically split the channel to avoid the interference. So you are lessening the overall bandwidth being used, so you are lowering your data rate, but you're doing it in a controlled manner that's easier to predict since you are specifically basically skipping over the chunk of spectrum that has interference on it, giving you a much more reliable and consistent data connection. So that's something really cool here, especially if you're going to be using 160 or 320 megahertz channels. So right now we have 3 access points that are Wi-Fi 7, the NWA130BE, the very similar WBE530, and the WBE660S. So I'll start going through all of those here for you guys. All of our access points come with a lifetime warranty. They use our RF first design technology when it comes to the structure of our access points and how we build them. So one of the things you will see if you open up our access points is we have a lot more shielding on the PCBA than you see with most of our competition, even our more expensive competitors. And basically that's there to provide greater isolation between possible overlap at the band edges between 5 and 6 gigahertz. It's also there to protect your data rate or data signals from interference from cellular technologies. So it's not something that would help you in a home, but if you're deploying our access points in a large office building, possibly large condo or apartment buildings, what happens is basically the cellular signals, which border 5 gigahertz and 6 gigahertz, can't penetrate the buildings well. So what happens in these new builds is they put in what's called a DAS system that distributes the cellular signal from outside the building inside the building. So basically you've got a set of what essentially look like access points, but instead of broadcasting Wi-Fi, they're broadcasting cellular. So what often happens in these environments is you have these cellular transmitters right next to your access points, simply because that's where the cable drops are in these buildings. And that can cause interference. So our shielding is there specifically to help reduce the interference from those LTE and 5G signals, which might be bordering your Wi-Fi radios in your access point. The other thing we do is we do not mount our antennas directly onto the main PCBA. You will find a second PCBA in the board on top of the main one, which the antennas are mounted to, rather than doing like most of our competitors and putting them directly on the main PCBA. And that just helps with EMI. Doesn't make a lot of difference when you've got a good, strong signal, but it can make a really big difference when we're talking about those edge users, the users where the signal's barely making it back to the access point. The other thing we do that you will find on our access points, it's different than a lot of our competitions, is we've designed these to last. So the two main causes of failure in a solid state product like this are going to be heat fatigue and capacitor failure. So to solve the capacitor failure issue, we do not use electrolytic capacitors in any of our access points. We instead only use solid state capacitors, which are much less likely to fail. And then the other thing we do is we take into account that heat fatigue situation. So most of our access points are going to find a large heat sink directly behind the main PCBA, which is designed to draw heat off of the main board and the main board components, and then plenty of vent holes to vent the heat out of the back of the access point. Or in some cases, such as our WBE660S, the back plate of the access point itself is a massive heat sink designed to pull that heat out of the main board. So going on here to the individual products, we'll start with our entry-level access point. This guy here has got a street price of $180, so it's very inexpensive, and it gets you a full tri-band Wi-Fi 7 access point. So you've got 2.4, 5, and 6 gigahertz all operating at the same time. From a class perspective, this is a BE 11,000 or 11 gigabits per second data rate on the wireless radios when combined. It's Nebula Flex, so it can be used as either standalone or it can be managed in our free Nebula cloud. And then we've got our WBE530. So the WBE530 is very similar hardware to the NWA130. And the primary difference here between the two is the WBE530 is a W series access point. So it is a Nebula Pro access point. It comes with 1 year of Nebula Pro license bundled with it out of the box. It also adds support for local controllers. So if you are using our ATP or USG Flex series built-in wireless LAN controller for local AP management, this also supports that. It also supports some advanced features when in Nebula, such as collaborative detection and response, CDR, and secure Wi-Fi features that are not found in the NWA130BE. And then both models on the back here take advantage of having a 2.5 gig multi-gig uplink port and a pass-through port, as well as the ability to be powered by a DC power adapter, as well as the standard PoE. And like our other access points, this guy comes with our pretty standard here rectangular mounting bracket, which has been designed basically to fit just about any situation you have. It's been designed to be able to be mounted directly to a wall or ceiling. It's got screw holes that have been designed to match junction boxes, outlet boxes, and then it also works with our T-bar mounting kit. So you can just snap those mounting kits onto a T-bar, attach this to that, and snap everything in place. And then on the high end of things, we have here our WBE660S. So this is our flagship access point. This is our high-end best of class product here for you. So it's faster. It's a 4x4 spatial streams on all three radios. So 2.4, 4, or 5 gigahertz and 6 gigahertz. All three of those are 4x4. It has a built-in Bluetooth BLE radio for various interoperability applications that you may have. And this guy here has our smart antenna technology in it. So I will have a couple slides where I talk about smart antenna for the, one of you out there that hasn't listened to me talk about it a million times. So here's what the back of the device looks like. So you'll see here, because this is a pretty heavy duty powered access point, it requires a lot of horsepower to provide, speeds of over 20 gigabits per second on Wi-Fi. So rather than putting a heat sink in the back and then having vent holes, we've made the entire back plate of the access point a giant heat sink to help pull heat out of the board to help allow us to give you guys that lifetime warranty. Now, to power this access point, again, because it is a pretty heavy-duty AP, it does require 802.3 BT PoE, otherwise marketed as PoE++. So that's the flavor of PoE that requires 60 watts of power per port. So that is required to power this access point up. So you will need a switch that provides that power. or you will need a PoE injector. We do sell a PoE 12-60W, which can fully power this up. And then on top of that, this can also be powered by a USB-C PD power adapter. So one of those standard PD power bricks that you could use to charge your phone or power up your laptop. As long as it can provide 60 watts of power, you can use that to power up this access point as well. And then because of the faster wireless data rate that it supports, it comes with a 10 gig Ethernet uplink port on it. And then mounting bracket is basically the same, obviously changed a little bit here to compensate for the heatsink back. But same thing, designed to basically mount anywhere you want to. So now I'll talk really briefly here about smart antenna. And basically, our smart antenna technology is very similar. For those of you that are familiar with Ruckus's BeamFlex Plus, it's a similar idea. Basically, it's designed to increase capacity. It's designed to help increase density, so reducing interference between different access points on overlapping channels, and just an overall increase your coverage. So your traditional access points have a single set of antennas that are basically designed with the idea that they're to be mounted directly over the area to be covered, and they radiate the signal out in what's roughly an umbrella pattern. So when you get interference, such as from other access points, industrial equipment, etc., it can cause some interference issues. So smart antenna is different. Instead of having a single antenna pattern, it has an array antenna setup that is capable of switching between hundreds of different antenna patterns. So it takes into account where the client device is in relationship to the access point, but also other sources of RF interference in relationship to the access point, and chooses an antenna pattern that's optimized for both factors. Now, smart antenna technology requires nothing special on the client device. It'll work with any client device that's out there, and it does work with mobile users who are moving around, something like beamforming does not do. So because of this, with our smart antenna technology, in a dense environment such as a hotel or apartments or condos, it basically allows you to achieve greater than 100% airtime utilization on channels. Because of the smart antenna technology, allows neighboring access points on the same channel to basically be able to broadcast at the same time without interfering with each other, or at least with lessened interference between them, allowing you in some cases to get up to 150% of available airtime, which theoretically is limited to a maximum of 100. And of course, all of these things here do work with our Zyxel Nebula, which is our free unified cloud management platform. You access it just by going to nebula.zyxel.com and logging in. Gives you a place where you can manage all of your customers, all of their sites, and all of their devices. So just to sort of highlight here the main differences between the three different access points here. From a basically just a pure hardware perspective, the NWA130BE and WBE530 are essentially the same as far as the configuration goes. I believe the WBE530 has some extra RAM to handle the extra software. So the main difference is why you would go with a WBE530 versus an NWA130BE would be because you want that bundled pro license and you don't want the hassle of needing to manually type one in yourself. You need that CDR functionality, collaborative detection and response, for increased security on your network. Or you want to use this access point as a secure Wi-Fi access point, which basically converts the access point into a cloud-managed VPN appliance that you can use to allow remote workers to easily connect back to the corporate office. And then the WBE660S basically doubles the speed. On the wireless side of things, gives you everything the WBE530 had, and then also adds in the Bluetooth beacon technology as well on top of that. All of them come with a lifetime warranty. So some applications here for why you would use or where you would want to use Wi-Fi 7. So one of the main areas where we see a big demand for Wi-Fi 7 is high density locations. places where you've either got a lot of users on the network or you've got a lot of access points crammed into an area, such as, a conference room or a meeting room, or an MXU deployment where you've got, dozens or hundreds of apartments, condos, hotel rooms, etc., each with their own access point. Another area here where we see it is when it comes to doing mesh networking. So you might remember probably, I think it was, maybe 15 years ago, there was a big marketing push in the business space to using mesh for business wireless deployments. And obviously that didn't go anywhere and kind of fizzled out, just because mesh technology, while it works great in a individual's home, doesn't have the latency or the reliability that was traditionally required of a business class network. And I think now with Wi-Fi 7, that's going to change, because you've now got that huge chunk of 6 gigahertz spectrum. You don't have to worry about interference between your different mesh nodes, and you've got really high throughput speeds. So you can have your users connecting on 2.4 and 5 gigahertz to the access point, and then use that super fast 6 gigahertz connection to make a mesh to backhaul those connections. And it solves a lot of those issues and makes mesh something now, I think, that's going to be something that can be used in a business class network environment. And then the other area here is anywhere where need a lot of high bandwidth or low latency applications. Thanks to MLO and those faster speeds on 6 gigahertz, you can send uncompressed video, reducing the latency there. And then you can use MLO to decrease latency even more. So it's great for video streaming, or just for situations where you're doing backups and transferring large files over your network. So that, guys, is the end of today's webinar. So go ahead and send in the questions. I see I've got 2. If you have any others, send those in using the question and answer part of the Zoom interface. And then just to highlight here real quick, if you go to YouTube, there are a bunch of different Zyxel channels there. The one for North America is literally just Zyxel America channel, all one word. So most of our webinars are recorded, and then they'll be uploaded generally within 24 to 36 hours to our YouTube channel. So if you missed a presentation or you want to share a presentation with one of your coworkers, you can find it there to share with them. We also have video case studies, best practices videos, new product introduction videos, etc. So it's worth checking out. And then if you'd like to connect with us on LinkedIn, again, there's a lot of different Zyxels on there. We are Zyxel US channel on LinkedIn. So I've got a question here from Michael, and I don't think I'm going to know the answer to this, but it is, when or will Zyxel be offering a layer 2 plus layer 3 switch with multi-gigabit capability, PoE++, and true serial port capability? So I know we've got ports out there, or multi-gig switches that have PoE++. I don't know about the serial port. I'm not the product manager for switches. So Win is who handles switches, and he might have a little better idea on that as far as if we have something like that on the roadmap. I'll be honest, I don't even know why you would want a serial port on a switch, but he would be who to ask. I would suggest, I'm guessing you're one of our partners if you've joined this webinar and it was advertised to you, reach out to your salesperson, Andy, Jacob, or David, with that question, and ask them to pass it along to Try. And they can get that answer for you. I don't know the answer. He is traveling today, so I don't have an easy way to get the answer in real time here for you. Joe has a question. Is there a limit to how many clients can connect to the smart antenna simultaneously? So the answer to that is basically the smart antenna does not reduce the number of client devices that can connect. In fact, it's going to allow you to connect more. So if you check the data sheet for any access point that's out there, there will be a max number of clients listed on it. But in the real world terms, you are going to have a lot of unhappy users well before you get too close to what is on the data sheet. And that just has to do with the way Wi-Fi works. Everybody is sharing the same finite amount of spectrum. So essentially, ignoring MIMO for the moment, just for simplicity's sake, basically every device has to take a turn broadcasting. The access point broadcasts, one client broadcasts, then another client broadcasts, then the access point broadcasts again. And so generally, because of those limitations, you will normally, if you have actual active users using the Wi-Fi connection, you will run into quality of the signal issues because of them stepping on each other's toes long before you get to whatever number is on that data sheet. And so smart antenna with the ability to basically ignore sources of RF interference in a multi-AP environment is going to let you get more clients on the same access point before you get interference issues caused by clients on those other access points. So, from a real world perspective in a true multi-AP environment, smart antenna will actually let you get more users on your access point before you start getting customer complaints about things. So hope that makes sense. Those were the only questions I had. So I am going to go ahead and end today's webinar. Thank you for joining us. If you missed it, I did sort of a tips and tricks best practices webinar a couple weeks ago for Nebula. We got a lot of feedback, a lot of questions on that. So I will be doing that webinar again towards the end of September. And I'm adding a lot more into it based on the feedback people provided. Questions people had, other topics that I didn't talk about that people had questions on. So I hope to see you there at the end of September when we talk about that. Thank you for joining us, and see you in a future webinar.